Section 14.3, ellipses. So, an ellipse is a locus of all points whose sum of distances to two fixed points, called foci, are always the same. So if I look at a point on the ellipse, and I look at the sum of these two distances, and I take any other point on the ellipse, and I look at the sum of the distances to that point, there, then these two sums are the same. So the same sum. Okay. So, for an ellipse, we have two foci, if I look at the line passing through the foci, then these points along the ellipse are called vertices. So here's another vertex. If I look at the midpoint between the foci, this is called the center of your ellipse. If I look at a line perpendicular to the, this line here is called the major axis. So if I look at a line perpendicular to the major axis, this is called the minor axis. And each of these 2 points are called vertices. So I have another vertex here. Here are the foci. Let me determine the equation of a ellipse. And let's say that I have an ellipse relative to some axes. And suppose, let me make it look more symmetric. A little bit better. Suppose that the focus here is at C0 and the center here is at 0, 0. And here's another focus at negative C0. Okay. Suppose that I have a vertex here at A0, negative A0, another vertex here at 0B, 0, negative B. Okay. And suppose that I take some point. Let me do it at a different angle. Let's take some point here along the ellipse. Let's say that this point has coordinates x, y. Then I know that the sum of these two distances will be the same as the sum of any other two distances along the ellipse. So let's look at this distance here along this axis. So if I just take this point here, then the distance from this point to this foci is going to be, well, A plus C. And distance from here to here is going to be A minus C. And it should be the same as this distance D1 plus D2. So this is going to be the distance C plus A plus, let's look at this distance here, which is just A minus C. And so I have that D1 plus D2 must equal 2A. Okay. Now let's look at these two distances here. Well, let's use the distance formula. So D1 is equal to the square root of the difference in the x coordinates, x minus a negative c squared, difference in the y coordinates, y minus 0 squared. Okay. And D2 is equal to the square root of, so that's the difference in their x coordinates, x minus c squared, plus the difference in their y coordinates, y minus 0 squared. Okay, so I must have that 2a is the same as the sum of these distances, the square root of. Let me multiply out x plus c, quantity squared. So that's equal to x squared plus 2cx plus c squared plus, well, y minus 0 is just y squared plus, well, let's figure out d2. X minus c quantity squared is just x squared minus 2cx plus c squared. Y minus 0 is just y squared. You get y squared. Okay. So now let me subtract it really doesn't matter which one I subtract. X squared minus 2cx plus c squared plus y squared from both sides of my equation. And so I have 2a minus radical x squared minus 2cx plus c squared plus y squared is equal to the square root of x squared plus 2cx plus c squared plus y squared. Let me square both sides of my equation. And so I get 4 a squared minus 4a rad x squared minus 2cx plus c squared plus y squared plus, well, the square gets rid of the square root, x squared minus 2cx plus c squared plus y squared equals, the square gets rid of the square root, x squared plus 2cx plus c squared plus y squared. Okay, so I can do a whole bunch of cancellations here. Let me subtract x squared c squared y squared from both sides of my equation. I want to add this to the other side too, so, well, and minus y squared. I guess I'll have to do it in 2 steps. So I get 4a squared minus 2cx. Oh, I should subtract the other 2cx. So minus 4cx, oops, minus 4a rad, and I want to bring that to the side of my equation, x squared minus 2cx plus c squared plus y squared equals 0. So let's add 4a rad x squared minus 2cx c squared plus y squared to both sides of your equation. Okay, so this is equal to 4a squared minus 4cx equals 4a rad x squared minus 2cx plus c squared plus y squared. Divide by 4. So I get a squared minus cx is equal to a rad x squared minus 2cx plus c squared plus y squared. Let me square both sides of my equation to get rid of the square root. And so I get a to the 4th minus 2a squared cx plus c squared x squared equals a squared times x squared minus 2cx plus c squared plus y squared. So I have, multiplying the a squared inside the parentheses, a to the 4 minus 2a squared cx plus c squared x squared is equal to a squared x squared minus 2a squared cx plus a squared c squared plus c squared y squared. Okay. So let me add 2a squared cx to both sides of my equation. Let me subtract c squared x squared from both sides of my equation. Let me subtract a squared c squared from both sides of my equation. Okay, so if I do that, I get a to the 4 minus a squared c squared is equal to a squared minus c squared x squared, cancel, cancel, plus c squared y squared. Let me factor out a squared. So I get a squared minus c squared equals a squared minus c squared x squared plus c squared y squared. Okay. Okay, so now let's divide both sides of my equation by a squared minus c squared. Oh, ooh. A squared times y squared is a squared y squared. Okay. So the a squared minus c squares cancel. So I get x squared over a squared plus y squared over the a squares cancel. A squared minus c squared equals 1. And one last note. If I look at this point here, I'll do it in orange. And so this distance here is just, well, this is b, that's c, so this is going to be b squared plus c squared, and this is b squared plus c squared. And so there are two of them, so this distance, so and I have to have that the same distance is also 2b squared plus c squared, since this is b and that's c. So this distance, so this is the square root of b squared plus c squared. And that's the same as, well, any of the other distances, 2a. And so that says that a is the square root of b squared plus c squared, squaring both sides. You get a squared is b squared plus c squared. And so b squared is a squared minus c squared. And so rather than writing a squared minus b squared, a squared minus c squared, I'm going to write it as b squared. So x squared over a squared plus y squared over b squared is 1. And that is the equation of my ellipse centered at the origin, where I've assumed that c squared equals b squared minus a squared. Where, well, I wrote it the other way around, but where I wrote it where interchanged a and b, where it's interchanged b and c, but it's the same condition. Now, if I had instead the vertices, the foci along the y-axis, everything would be the same. The only difference is really the fact it would be a squared minus b squared. So I'm just going to put absolute value here. And that is the equation of an ellipse. Now, if instead we have the equation of an ellipse centered at, say, hk rather than 0, 0, then the equation would be x minus h squared over a squared plus y minus k squared over b squared is 1, where c squared equals b squared minus a squared in absolute value. So that's the equation of an ellipse centered at the point hk. Whereas this is the equation of an ellipse centered at the point 0 at the origin. Notice that the vertices in this case, are at plus or minus A, 0, 0 plus or minus B, and the foci, well, the foci have coordinate, one of the coordinates being C. So depends on if they're along the X or Y axis. And here the vertices are at A, at H, plus or minus A, K, H, K plus or minus B. And the foci, well, I'll say that H plus or minus C, K, or H, K plus or minus C. So it depends on, just like in the above case, so the foci here are at plus or minus C0 or 0 plus or minus C. So depending on if the foci are along the X or Y axis, or in this case, if they're parallel to the X or Y axis. If the major axis is parallel to the X or Y axis. Okay, so let me give you some examples of when you would be seeing ellipses. So example. Okay, so suppose you have here the sun, and you have here the Earth, and it's in orbit around the sun. It turns out that the orbit will look like an ellipse, and the center of the sun will actually be at one of the foci. It turns out that if you have any sort of celestial objects, any two-body, so any pair of celestial objects where one object is orbiting about the other object, they will orbit in an elliptical orbit. Okay. Another example is a whisper room. So a whisper room is a room that is ellipsoid in shape. And there are these two little markings. And so in a whisper room, if you happen to be located at one of these two little markings, which turn out to be the foci of this ellipse, and if you happen to whisper, it turns out that you can actually hear the person across the way, just due to the fact that you're able to hear it that far. So whisper room. So if you say something like really, really low, they can actually hear you, whereas the person next to you may not be able to hear you, but the person across the way can, because, well, your sound keeps bouncing off all of the walls, and they're concentrated just at this one person here. Okay. Next. Suppose there you are. Suppose that you come into a hospital complaining about pain, and you have they find out that you have um, gallstones. One of the cures for a gallstone would be that they would place you into a bath that's ellipsoid. That's an ellipse. It's an ellipsoid, and they put water in here, and they put you in there, and then what they do is they vibrate the edge of this pool, and the water comes and well, all the waves concentrate upon your gallstone and destroy it. hmm So if you have like a gallstone, okay. Let's do some examples. Let's say on page 600. Let's do problem number 1. In exercises 1 through 14, graph the ellipse. X squared over 16, y squared over 4 equals 1. So I want to graph this, give the lengths of the major and minor axes. Okay, so first off, the center of this ellipse is at the origin because you're not subtracting anything from x or y. A in this case is, well, the square root of 16 is 4. B, the square root of 4 is 2. C, 16 minus 4 is 12. And so C is the square root of 12. So let's graph this. Oh, the length of the major axis is 8 because it's double the 4. The length of the minor axis is 4. Major because 4 is bigger than 2. And the length of the minor axis is going to be 4 because 2 times 2 is 4. The length of the major axis is 8 because 2 times 4 is 8. Okay, so let's try to graph this. So the center's at the origin. You go off 4, 1, 2, 3, 4, 1, 2, 3, 4. In the x-axis, 1, 2 in the y-axis. And this is your, yeah, whatever. This is your ellipse. Here are your vertices. At 4, 0, negative 4, 0, 0, -2, 0, 2. The foci are at the square root of 12, which is about here or something. So here are your foci at 2 rad 3. And of course the center is at the origin. Okay, let me do problem number 3. X squared over 36, y squared over 16 is 1. The center again is at the origin. A is 6, B is 4, C, 36 minus 16 is 20, so the square root of 20, 2 rad 5. The length of the major axis is going to be 2 times 6 is 12. The length of the minor axis, so the minor diameter is 8. Let's draw this. Again, the center is at the origin. So we go 6. 1, 2, 3, 4, 5, 6. 6 in the X, and 4, 1, 2, 3, 4, 1, 2, 3, 4 in the Y. I guess I'll do the bounding rectangle. So let me draw the bounding rectangle. So you're inside this. Okay, so this is your ellipse. You're at 2 rad 10, so square root at 6. So it's around here. So this is your foci. Here are your vertices. And here's your center. Okay. Let me do problem number 5. X squared over 25, y squared over 36 is 1. Again, the center is at the origin. A is 5, B is 6, C is 36 minus 25, 11. The major axis, 6 is bigger than 5, so 2 times 6 is 12. The minor, length of the minor axis, 5 is smaller than 6, so 2 times 5 is 10. Let me draw. So 5, 1, 2, 3, 4, 5, 4, 5, 1, 2, 3, 4, 5, 6, 4, 5, 6. Draw the bounding rectangle. So it looks something like this. Square root of 11 is about here. So that's your foci, your center, your vertices. Okay. Okay. Let me do problem number 7. x squared over 9, y squared over 25 equals 1. The center is at the origin. A, the square root of 9 is 3. B, square root of 25 is 5. C, 25 minus 9 is 16. The square root of 16 is 4. The length of the major axis, 2 times 5 is 10. Minor axis, 2 times 3 is 6. Let's draw the ellipse. So 1, 2, 3, 1, 2, 3, 3, 4, 5, 1, 2, 3, 4, 5. Okay, so in 4, 1, 2, 3, 4. So let's draw this ellipse. So here are my vertices, here are my foci, and here's the center. Maybe I'll write so the vertices are at plus or minus 3, 0, 0 plus or minus 5, foci at 0 plus or minus 4. 9. Four x squared, 36y squared equals 144. Divide both sides of your equation by 144. And so x squared over 36, y squared over 4 is equal to 1. The center is at the origin. A, square root of 36, 6. B, square root of 4, 2. C, 36 minus 4, 32. So the square root of 32 for rad 2. The length of the major axis, 2 times 6, 12. Minor axis, 2 times 2, 4. Since here's the origin, go 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Okay, and then 1, 2, 1, 2. Okay, so center, vertices, and then the foci. So my ellipse looks something like this. Yeah, whatever. Okay, so it looks something like that, more or less. Problem number 11. X squared, 9y squared equals 9. Divide both sides of my equation by 9. X squared over 9 plus y squared over 1 equals 1. Okay, so the center is at the origin. A is 3. B is 1. C, 9 minus 1 is 8. The square root of 8. 2 rad 2. The length of the major axis. 3 times 2 is 6. Length of the minor axis. 1 times 2 is 2. So A is 1, 2, 3, 1. It's very flat. So here are my vertices, center, and my foci. And so it should look something like this. And that's my ellipse. 13. $25 x squared 9y squared 225. Divide both sides of your equation by 225. X squared over 9 y squared over 25 is equal to 1. So the center is at the origin. You're not subtracting anything from x or y. A is 3. Square root of 9 is 3. B, square root of 25 is 5. C, 25 minus 9 is 16. Square root of 16 is 4. The length of the major axis, 5 times 2 is 10. Minor axis, 3 times 2 is 6. Okay, so 1, 2, 3. 1, 2, 3, 4, 5. 4, 5. Okay, so vertices, foci, center. Draw the ellipse. Okay. 15. X minus 1 squared over 9. Y squared over 1 is equal to 1. So in this case, the center is at 1, 0. A, square root of 9 is 3. B, square root of 1 is 1. C, 9 minus 1 is 8. Square root of 8, 2 rad 2. The length of the major axis. Oh. Oh, yes, it is. So in exercises 15 through 26, find the center HK and the length of axes and graph each of the given ellipses. So the length of the major axis, 3 times 2 is 6. Minor axis, 1 times 2 is 2. Okay, oh, maybe I should say where the vertices are. So the vertices will be 1 plus or minus 3, 0. So that's going to be a negative 2, 0, and 4, 0. In addition, I have vertices at 1 plus or minus 1. My focus, well, it'll be along the x-axis, because along in the x direction, because because 3 is bigger than 1, and so it's going to be 1 plus or minus 2 rad 2, 0. Okay, so let's go here. So okay. So my center is at 1, 0. My vertices are at 1 plus or minus 1 and negative 2 and 4. My foci, 1 plus, that's pretty close. My foci are here. So foci, center, vertices. And this is what the, oops. More or less. And that is a graph of the ellipse. 17. X squared over 4. 17. Y minus 1 squared over 9 equals 1. So the center in this case is 0, 1. A, square root of 4 is 2. B, square root of 9 is 3. C, 9 minus 4 is 5. So C is the square root of 5. The length of the major axis, 3 times 2 is 6. Length of the minor axis, 2 times 2 is 4. And so we're here at 0, 1, and you go 2 in the x, 1, 2 in the x, and 3 in the y. 1, 2, 3, 1, 2, 3. Okay. Looks something like this. Here's the center, vertices, and foci. Okay, and here's my ellipse. So my vertices are at plus or minus 2, 1, and at 0, 1, plus or minus 3, the foci are at 0, 1, plus or minus rad 5. 19. X plus 1 squared over 2 squared. Y minus 3 squared over 3 squared equals 1. Okay, so the center is at negative 1, 3. A is 2. B is 3. 9 minus 4 is 5. And so C is the square root of 5. It's the same problem. We just shifted it. Okay. So it's the same ellipse as the previous problem. The length of the major axis is 6. The minor axis is 4. The vertices are at negative 1 plus or minus 2, 3. Negative 1, 3 plus or minus 3. The foci are at negative 1, 3 plus or minus rad 5. So the center is at negative 1, 3. 3. Okay, so you go 2 in the x. Okay. 3 in the y. So you go rad 5. So here are my vertices, foci, center, and my ellipse. 21. x minus 2 squared, 5 squared, y minus 3 squared, 4 squared. So the center is at 2, 3. A, 5, B, 4. C, 25 minus 16 is 9. Square root of 16 is, square root of 9 is 3. The length of the major axis, 10. Minor axis, 4. The vertices are at 2 minus 5, negative 3, 3. 2 plus 5, 7, 3. 3 minus 4, negative 1. 3 plus 4, 7. The foci are at 2 minus 3, negative 1. 2 plus 3, 5. Okay. So 5. Oh, 2, 3. Okay. You go at 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay. So let me draw the ellipse. Vertices. Center. And foci. 23. $23. 4. X minus 1 squared. 16. Y minus 3 squared is 64. So x minus 1 squared over 16 plus y minus 3 squared over 4 is equal to 1. Dividing both sides of my equation by 64. So the center is 1, 3. A is 4. B is 2. C, 16 minus 4 is 12. Square root of 12. 2 rad 3. The length of the major axis is 8. Length of the minor axis is 4. The foci of the vertices are located at 1 minus 4, negative 3, 3. 1 plus 4, 5, 3 at 1 comma 3 minus 2 is 1. 3 plus 2 is 5. And the foci are at 1 plus or minus 2 rad 3, 3. Let's draw this. So 1, 3, you go 4. Okay. 1, 2, 3, 4. Okay. And 2. Okay, so center is at 1, 3. And then you go 4 in the x, 2, 4 in the x, and 2 in the y. And so here's my bounding rectangle. Here's my ellipse. So vertices. Focus. Square root of 12. It's about here. So here's my foci. Here's my center. And that's the ellipse. 25. 4 x plus 2 squared, 9 y plus 1 squared is 36. Divide both sides of the equation by 36. X plus 2 quantity squared over 9, y plus 1 squared over 4 is 1. Center is at negative 2, negative 1, A, 3, B, 2, C, 9 minus 4, 5. Length of the major axis, 6. Minor axis, 4. Okay, so negative 2, negative 1, as the center, you go 3 in the x. 1, 2, 3, 2, 3. 2 in the y. 1, 2, 2. Okay, so this is my ellipse. Center, vertices, foci, about here. So the vertices are at negative 5, negative 1, 1, negative 1, -2, -3, -2, 1, and the foci is at a -2, -1, plus or minus rad 5. Oops. 3 is bigger than 2. I wrote it the wrong way. -2 plus or minus rad 5. -1. And those are your center vertices and foci. 27. Four x squared, 9y squared, minus 8x, 54y, plus 49. In exercises 27 through 36, use completing the square method to convert the equation to standard form for an ellipse, then sketch the graph of the ellipse. Okay, so group x's together, y's together. Bring the 49 to the other side of your equation. Factor out the 4 to complete the square. Factor out the 9 to complete the square. Okay, so let's complete the square. -2 divided by 2, -1 squared is 1, times 4 is 4. -6 divided by 2 is a -3, squared is 9, times 9 is 81. +485 minus 49 is 36. Divide both sides of your equation by 36. X minus 1 squared over 9 y minus 3 squared over 4 is equal to 1. So the center of your ellipse is at 1, 3. A is 3. B is 2. C is the square root of 5. And so let's sketch this. So the center is at 1, 3. You go 3 in the X, 2 in the Y, And so your ellipse looks something like this. Center, vertex, and the foci so the vertices are at 1 minus 3, negative 2, 3. 1 plus 3, 4, 3. 3 minus 2. 3 plus 2. And the foci are at 1 plus or minus, we're at 5, 3. $29. 25 x squared 9y squared plus 50x equals 200. Okay, so let me factor out the 25 and group the x's together. Factor out the 9. Actually, I'll just write it as 9 since it's already completed. The square was completed on that term. Okay, so now let me complete the square. 2 divided by 2 is 1. 1 squared is 1 times 25 is 25. Divide both sides of your equation by 225. So you get x plus 1 squared over 9 plus y squared over 25 is equal to 1. So the center of your ellipse is negative 1, 0. A is 3. B is 5. 25 minus 9 is 16. The square root of 16 is 4. The length of the major, well, I'll just do vertices. So your vertices are at negative 4, 0, 2, 0, negative 1, negative 5, negative 1, positive 5, and the foci are at negative 1, negative 4, negative 1, positive 4. Let me draw my ellipse. So we're at negative 1. That's my center. Go 3 in the x. 1, 3 in the x. Go 5 in the y. And so let's see, the foci. And so let's draw this ellipse. Good enough. So here the vertex. Here's another vertex. Center. Here's a focus. Here's another focus. 31. Well, then I could have brought this down a little bit. Okay, maybe not. There. Okay, good. Let me do problem number 31. Nine x squared, 4y squared, 18x, 16y equals 11. So let me group the x's together and the y's together. Nine x squared minus 18x, 4y squared plus 16y equals 11. So I have 9 x squared minus 2x plus 4 y squared plus 4y equals 11. Negative 2 divided by 2 is negative 1. Squared is 1 times 9 is 9. 4 divided by 2 is 2. 2 squared is 4. Times 4 is 16. 11 plus 9 plus 16 is 36. Divide both sides of my equation by 36. So x minus 1 squared over 4. Y plus 2 squared over 9 equals 1. So the center is at 1, negative 2. A is 2. B is 3. C is 9 minus 4 is 5. And so the square root of 5. The vertices are at negative 1, negative 2, 3, negative 2, 1, negative 5, 1, 1. The foci are at 1, negative 2, plus or minus rad 5. And let's go a little over. Okay, looks a little. Oh, this one's never going to be straight with this keyboard. Let's try that. Oh, I got it. Okay. So the center is at 1, -2. I go 2, 1, 2 in the X. 1, 2 in the X. I go 3, 1, 2, 3. 1, 2, 3 in the Y. And then rad 5. And so my ellipse should look something like this. Here are my vertices. Center, foci. 33. Again, I could have pushed it down a little bit. Okay. Problem 33. 25 x squared 9y squared 100x 36y 89. Group x's, y's together. Factor out 25 from the x's, 9 from the y's, complete the square. -4 divided by 2, -2 squared is 4 times 25, 100. 4 divided by 2 is 2, squared is 4, times 9, 36. And so 89 plus 100, 189 plus 36, 225. Divide both sides of your equation by 225. So x minus 2 squared over 9, y plus 2 squared over 25 is equal to 1. So the center is at 2, -2, A, 3, B, 5, C. 25 minus 9 is 16 squared. 16 is 4. The vertices are at -1, -2, 5, -2, 2, -7, 2, 3. The foci are at 2, -6, and 2, So the center is at 2, -2. I go 3 in the x, 1, 2, 3, 1, 2, 3. 5 in the y, 1, 2, 3, 4, 5, 2, 3, 4, 5. And so my ellipse will look something like this. And the foci, so 4. 2, 1, 2, 3, 4. What the heck? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Okay. There. 1, 2, 3, 4. Okay, better. 1, 1, 2, 3, 4. Okay, there. So here are my vertices, my center, and my foci. And that is my ellipse. I miscounted going up. 35. 9 plus 16y squared minus 64y minus 80 equals 0. So I have a 9x squared plus, factor out 16 from the y's. 16y squared minus 4y. Add 80 to both sides of your equation. Now let's complete the square. -4 divided by 2 is -2. Squared is 4. Times 16 is 64. Divide both sides of the equation by 144. So x squared over 16 y minus 2 squared over 9 equals 1. So the center of my ellipse is 0, 2. A is 4. B is 3. 16 minus 7. 16 minus 9 is 7. So C is the square root of 7. My vertices are at -4, 2, 4, 2, 0, -1, 0, 5, and my foci are at plus or minus rad 7, 2. Okay. Let's draw this. I have to go 3 in this direction. Okay, so it's at 0, 2. I go 4, 2, 3, 4, 1, 2, 3, 4 in the X. 3, 1, 2, 3, 1, 2, 3 in the Y. So here's my ellipse. And the foci at rad 7. It's about there. Okay, so here are my vertices, center, and foci. 37. Plus or minus 2. 0. 0 plus or minus 3. 37. Okay, give the standard form of the equation of the ellipse of center 0, 0. So that says if it has center at 0, 0, then it must be of this form with the given x and y intercepts. Okay, so I have the given x and y intercepts. So that says, so let's plug in for x plus or minus 2 squared, 0. So from that, I get 4 over a squared is 1. So it says a squared is 4. Okay, let's plug in the other one. I have x is 0. I'll just say over a squared. Y is, I can either pick plus or minus 3. Doesn't matter. And so that says that 9 over b squared is 1. So it says b squared is 9. So therefore, I have the equation. X squared over a squared, 4, plus y squared over b squared, 9, is 1. And that is the equation of my ellipse. 39. Plus or minus 5, 0, 0, plus or minus 7. Okay. Since it's centered at the origin, then I know that the major or minor axis is along the x-axis, and the major or minor axis is along the y-axis. Therefore, I know the x and y intercepts give me A and B, and so from here I get A is 5, B is 7. The equation of my ellipse is x squared over a squared plus y squared over b squared is 1. Therefore, x squared over, since it's centered at the origin, over 25 plus y squared over 49 is 1. And that is the equation of my ellipse. 41. X squared over 9, y squared over 16 is 1. In exercises 41 through 48, using c squared equals absolute value of a squared minus b squared, name the focus of the ellipse with the given equation. Okay, so let's figure out where the focus is. So a is 3, b is 4, 16 minus 9 is 7, so square root of 7. And so that's, and since the center is at the origin, then this says that the foci are at O. And since B is bigger than A, that means where foci is going to be along the y-axis. It's at 0 plus or minus rad 7. Let's do 43. X squared over 25, y squared over 36 is 1. And so A is equal to 5, B is equal to 6. 36 minus 25 is 11. So C is the square root of 11. Since the center is at the origin, and since B is bigger than A, then the foci are at 0 plus or minus rad 11. 45. Four x squared plus 36y squared equals 144. Divide both sides of the equation by 144. So we got x squared over 36 plus y squared over 4 is equal to 1. So A is 6, B is 2, C, 36 minus 4 is 32. So 4 rad 2. Since the center is at the origin, and since A is bigger than B, then the foci are at plus or minus 4 rad 2, 0. 47. X squared plus 9y squared is equal to 9. Divide every term here by 9. So we get x squared over 9 plus y squared over 1 equals 1. So the center is at the origin. A is 3. B is 1. 9 minus 1 is 8. And so C is the square root of 8, 2 rad 2. Since 3 is bigger than 1, since A is bigger than B, then the foci will be at plus or minus 2 rad 2, 0. 49. the foci are plus or minus 2, 0. In exercises 49 through 59, find the equation of the ellipse given the foci and vertices. The vertices, well, two of the vertices are given. They're at plus or minus 4, 0. Well, the midpoint of the foci is the center of the ellipse. So if you add 2 plus a negative 2, you get 0. And so the center is at the origin. So the equation of my ellipse is just x squared over a squared plus y squared over b squared is 1. So I have the following, that a is given here as 4. C is given here as 2. I have that c squared equals, since the foci are along the focal axis, the major axis, then which is, if you notice, along the x-axis, and the vertices here are along the x-axis. That means that this must be the major axis. And so a squared must be bigger than b squared. So I have 2 squared is equal to 4 squared minus b squared. So b squared is equal to 16 minus 4, which is 12. Therefore, the equation of my ellipse is x squared over a squared, 16, plus y squared over b squared, which is 12. And that is the equation of my ellipse. 51. The foci are at plus or minus 5, 0. Two of the vertices are at plus or minus 7, 0. So the midpoint of the foci is just the origin. Therefore, the equation of my ellipse is x squared over a squared plus y squared over b squared is 1. A is 7. We don't know b. C is 5. C squared equals a squared minus b squared. Again, a is bigger than b since the foci along the focal axis, the major axis, is the x-axis, and they've given us the and so a is bigger than b. So I have 5 squared is equal to 7 squared minus b squared. So b squared is 49 minus 25, 24. So the equation of my ellipse is x squared over a squared, 49, plus y squared over b squared, 24, equals 1. And that is the equation of my ellipse. 53. The foci the foci are at 0, plus or minus 4, 53. And two of the vertices are 0, plus or minus 6. So again, the center, the midpoint of the foci, is the origin. And so the equation of my ellipse must be x squared over a squared plus y squared over b squared is 1. A, don't know. B is 6. C is 4. I know that c squared is equal to b squared minus a squared. Since the foci are along the focal axis, which is along the y-axis, the major axis is along the y-axis, then b is bigger than a, and so I have c squared is b squared minus a squared. And so 4 squared is 6 squared minus a squared. So a squared is equal to 36 minus 16, which is 20. So the equation of my ellipse is x squared over a squared, 20, plus y squared over b squared, 36, is equal to 1. And that is the equation of your ellipse. Let me do problem number 55. The foci, 0 plus or minus 3, 53, and to the vertices, 53, not 50, 55, 55. The foci are at 55. 0 plus or minus 3. To the vertices, 0 plus or minus 5. So the center of your circle, of your ellipse, center of your ellipse, is at the origin, since the midpoint of the foci is the origin. By the way, of course, a circle is a very special ellipse. Is an ellipse where the major and minor axes have the same lengths, and so the two foci really sort of go into the center. Okay. A, don't know. B is 5. C is 3. So c squared is equal to b squared minus a squared. Since the foci are along the y-axis, so the focal axis, the major axis, is along the y-axis, and the vertices along the y-axis are the b, and so b is bigger than a. 3 squared is equal to 5 squared minus a squared. So a squared is 5 squared minus 3 squared, 16. So since the center is at the origin, the equation of my ellipse is x squared over a squared plus y squared over b squared is 1. So the equation is x squared over 16 plus y squared over 25 is 1. And that is the equation of my ellipse. 57. The foci are at 57 plus or minus 3, 0. And the length of the minor axis, 57, the length of the minor axis is 6. Okay. And so the major axis goes along the x-axis. Since the foci are along the major axis, which is in this case, the x-axis. And so this says here that 2b is equal to 6. And so b is 3. Since the foci are at plus or minus 3, 0, then the midpoint of the foci is just the origin. So I have here A, don't know, B, 3, C is 3. Oh, that's the minor axis. Okay. Okay, so I have here c squared equals a squared minus b squared. And so 3 squared is equal to a squared minus b squared. So a squared is equal to 9 plus 9, which is 18. And so, since the center is at the origin, the equation of my ellipse is x squared over a squared plus y squared over b squared is 1. And therefore, the equation of my ellipse is just x squared over 18 plus y squared over 9 is equal to 1. And that is the equation of my ellipse. 59. The foci are at plus or minus 2, 0. Which says that the center is at the origin. Which says that the equation of my ellipse is x squared over a squared plus y squared over b squared is 1. And 59, the length of the major axis is 10. So the major axis, since the foci are along the focal axis, the major axis, which in this case is along the x-axis, then that says that 2a is 10. So a is 5. Let's do this. A, B, C. So A is 5. Don't know B, but C is 2. I have that C squared is equal to major axis. So A squared minus B squared. A is bigger than B since the major axis is along the x-axis. So C squared, 2 squared equals A squared, 5 squared minus B squared. So B squared is equal to 25 minus 4, 21. And so The equation of my ellipse is x squared over a squared plus y squared. X squared over a squared, 25, plus y squared over b squared, 21, is equal to 1. And that is the equation of my ellipse. And so that finishes off section 13.3, I think this is.